Welcome back to this PI-KEM video series, where we're taking a deep dive into how to create a coin cell. I'm Georgia, and in this video we're going to be covering the second stage of coin cell fabrication, the electrode slurry coating. In the previous stage, we prepared our electrode slurry, carefully mixing active materials, binders, conductive additives, and solvent to create a uniform and homogeneous electrode slurry. Now, in the next stage, we're going to be transforming this slurry into a functional electrode by coating it onto our metal foils. The quality of this coating directly determines how the coin cell will perform. Precise coating creates the uniform electrode surface, which is essential for cell performance. The coating process must achieve uniform thickness, consistent material loading, minimal defects, and strong adhesion to the metal foil. Getting a good coating requires careful control of coating speed, slurry consistency, and blade height. In this video, we'll walk you through the principles, equipment, and practical steps needed to produce a high-quality electrode coating, showing you what to look for and what to avoid as you do it. Before we begin coating, we need to choose the correct current collector. For cathodes, we typically use aluminium foil, whereas for anodes, we use copper foil. The doctor blade controls the thickness of the coating by setting the gap between the blade and the foil. This distance can be precisely tuned using micrometer screws. As the blade moves across the substrate, it spreads the slurry into a precise layer. If the gap is too large, the coating will be too thick. However, if it's too small, coverage may be incomplete. Positioning your substrate onto your flatbed coater requires careful attention. The foil must lay completely flat. Any wrinkles in the substrate surface will directly translate into electrode defects. Use the vacuum bed or temporary adhesive tabs to ensure that the foil remains perfectly stationary throughout the coating process. Pour the slurry in front of the doctor blade with enough volume to cover the full width of the foil. For this demonstration, we're using gouache paint as a visual substitute for electrode slurry. At this stage, a common mistake is applying too little material, which leads to incomplete coverage of the electrode foil. To improve consistency between coating runs, a slot die coating head can be used instead of a doctor blade. A slot die coater can be used in combination with an automated syringe pump, which delivers a defined volume of slurry at a precise rate as the coating head passes across the foil. Set your chosen coating speed and the distance that the blade will travel. The relationship between coating speed and slurry consistency is critical, and these parameters often need to be optimized together. As the coater pushes the doctor blade across the substrate surface, observe how the slurry spreads out behind the blade. Coating speed influences how evenly the slurry distributes across the substrate surface, the quality of the edges, and the overall uniformity of the slurry layer. You'll need to find the right speed for your particular slurry to get the highest quality electrode coating. Once the coating is complete, the electrode must be carefully dried and, in many cases, compressed to achieve the final structure required for cell assembly. Some slurries can be left to air dry, whereas others benefit from heated coaters with top or bottom heating elements to assist in drying. In the next stage, we'll take a look at how drying and calendaring transforms this coated foil into a finished electrode ready to be built into a coin cell. A high-quality electrode coating shows clear indicators. You should see uniform thickness across the entire area, a smooth surface free of streaks or blotches, and clean, well-defined edges with no inconsistencies. To wrap up this video, let's have a look at some common coating defects. Uneven thickness usually results from incorrect blade settings or inconsistent slurry properties. Striations often indicate contamination or lumps within the slurry. Incomplete coverage points to insufficient slurry volume or poor wetting of the foil. Line defects are often caused by clumps in the slurry or damage to the blade edge. Recognizing these defects allows you to quickly diagnose and correct the underlying issue. Overall, achieving a high-quality electrode coating requires balancing several key factors: the right foil, a flat and secure substrate, the correct doctor blade gap, steady coating speed, consistent slurry feed, and the right viscosity of coating. At PI-KEM, we can supply a wide variety of metal foils, as well as flatbed and roll-to-roll coaters, syringe pumps, slot dies, and doctor blades. We can also supply a broad selection of pre-coated electrode foils if you want to skip this step entirely and move straight to cell assembly. Explore our full range on our website or get in touch with our expert team to discuss how we can support your battery research journey.